Hey everyone. So I'm starting my first part of the series for kind of text manipulation. So this one will go over concatenating, and I think this is honestly the best way to go about it. It's the most basic, and you can find it under here, or if you hold Control Alt, it's right there. Excuse me, I have a really sore throat for some reason. I must need to drink more water. Anyways. So they were going to go over concatenating. So we can get rid of these for now. Put these to the side. So what is concatenating? So basically all it does is have it outputs text, but in a format that you want it to be in. So it's basically like making a sentence. So with these tutorials, you want to use panels a lot, so you know what's going on. I think with more than any of them, you need to know what's going on. But with panels, you can start to type out like, I don't know, we'll just type out like hello for now. Put hello. And then we'll just put hello world. Just like everyone else does. But you can see it's one word here, so we need to add a space. You can either add a space in there. So you can add a space in the actual word, or if you don't want to do that, you can add it in the panel itself. So you just add a space. You make it, make it pretty small here. You don't need it super big. And then add the other one. And I should sorry, I almost up with my throat. I should mention that to have all those panels, or if you want to add more, you have fragment A, fragment B, and then the other ones. So if you zoom in, you can actually click plus and add more segments too. So you can see that world, and then hello is here as well. So give me 1 second. Sorry, don't know. Apologies for that. So we have all these here. So this is pretty basic, very, very simple. So if we get rid of all these right now, this is a very basic example. So what can we really do with this? So what we're going to do is we're going to make something very quick. So I'll make in Grasshopper, I'll make a rectangle. And I'll make it 12 by 12, 12 by 12 square. And then I'll make basically a tiled floor, and we're going to label it using concatenate as well properly. So we'll move it in the X as a series, and then as Y with series as well. So X, I'm going a little faster with this one because this one's pretty basic stuff. So basically just making a bunch of rectangles and then doing series, and I'm moving it a certain amount. Probably can do the step can be 12, and here, yep, and then addition. So you guys didn't know, you can right click and add expressions into here instead of making addition. So I can do like x plus 1 to add a 1 spacing here. Same thing here, add x plus 1, and then commit the changes, and now you have your spacing, which is a 1-inch spacing. And I should probably change this to metric. I do not like using imperial units. They're very annoying to use. So we have that, and it's going diagonally, so we need to graft this. There we go. And now we have tiles of space. How do I turn off my grid? Grid off, is it not? I can't remember exactly how to turn off the grid in here, so that's my bad. I know there's a way. I just cannot remember. Is it just G? No, I don't remember. I know in 3ds Max it's different. So anyways, so we have our panels here. You guys can see that it looks like, at least for my screen. So what we're going to do with these is we're going to label each one of these like a specific name. So like if we want to name it, like if we start here and this is a north side, for example. So if we draw an arrow in Rhino, I'll just draw a quick north arrow. So all these pieces here are north. So I want north 1, north 2, north 3, north 4, north 5, north 6, 7, 8, 9. Or it could be the other way around. 1, 2, 3, 4, 5. Yeah, these are spaced correctly. All right, so I may just do it going ascending from bottom to top here. So I want to label it like that. So the first thing to do, I like to do, is make sure everything is actually correctly ordered. So I do a list item real quick, and first flatten all this. I don't need all of them in one. And we see it's going in the right order, which is good for what we need. If we want it in the other way, I'll show that later. So let's say we want this to say, put north. I'll put in all caps right now. North, we'll delete all this. North, and then we'll put a dash. Now, I like to separate mine out, but it's up to you and up to preference. But you can put north dash, and then it's going to be going by number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it'll go back to 1. So what we need to do is make sure that north, it should be north 1, north 2, north 3, north 4, north 5, north 1. We may can keep this unflattened. We may want to do this. So what we want to do now is we have our text and we're like, okay, so we need to get the numbers now. So north, we add a series and we get numbers here. So north 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But we want the whole list count. So, all right, Mr. Left 4 Dead person. So what we can do is add a list length to get the total. Oh, that's length of the list length. And this will give us the total amount in that list. We can actually, we'll just flatten this for now and see what result it gives us. So now we have 100 of them. It looks like 100, yep. And then you should give out, 10 here, so that makes sense. Okay, and now we want to label them. So we want to label them using either, we could use center or polygon center, or you can use area. So you can use either one of these three. Technically, the most computationally efficient are these two, if they're 2D, or if it's 2D, this one. This one's technically the best. It's a plugin, though, from, I don't even know how to say that name, Heperotra? I don't know how to say that name. But this one's technically the most efficient. But this one, if you just want to use native Grasshopper, since this is 2D, most efficient. If it's 3D, then we stick with this. Or if you really want to, if it's very three-dimensional, just use volume as well. This gives out information you usually you would use. I guess if you just want the centroid. So, but we'll stick with the polygon center for now. And then we'll start with a text tag as well. So text tag is located here. So what we're going to do is start with this text tag. We're going to use the location. We'll use one of these. And we'll add the text and see what it does. So what results do we get exactly? We'll do a text tag 3D actually. So we can change the size. This one I think is easier to use. So here, and delete that. So it goes from north 0, and you're like, this works pretty well. It names all 100. But there's a problem. There's a problem here. So it's going to this right here. It's 0. So all we need to do is change this to 1. The starting point to be 1. And now we have 1 through 100 instead of 0 through 99. Because technically when you're labeling stuff, you don't want 0. It doesn't really make much sense. So, okay, so now that we labeled this, we're like, okay, cool. But once if I want it to be like north 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then start back at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what we need to do there is use the grafting we had. So if we don't flatten this, you can see that all the numbers are the same. But then now you can't identify what piece is which. So it's like north 1, you need north 1, north 2, north 3, north 4. So usually what we would do is we'd say north 1 here, and then north 2, and then 3, 4, 5, 6, 7, 8, 9, 10, as you can see here. But we need a way to identify which row it is. So we would say like 1 north 1, and then 2 north 1. So we know that's the second row in the second column in the first row. That was a tongue twister, just realized. So what we want to do here is make sure we have our labels correct. So we want to add a specific amount here. So what we want to do is, I think what we can do is just add another series. We can also just use this list length here. We add this, and then we just put a 0 here. And that should work pretty well. As long as we have the same starting. 1 north 1. We should have 2 here. We want it to be with this list here. It says 1 north 1. We want to probably flip it. Something about this. We probably need to flip the matrix. Put that there. 1 north 1, 2 north 1, 3 north 1. Okay. So what we just did here is we wanted to make, what I was trying to make sure of is that instead of it reading like this, so let's say I plug this back in right now. And also, let me justify this to the center. Middle center. All right, cool. So let me turn everything off here, just for the sake of how I guess you guys can understand this. What we want is some way to identify what column we're in, what row and column. So each individual tag is unique. Right now, all these norths are the same. All these norths are the same. And all these are the same, etc. Each column is unique though, but each row is the same. But we want each row and column to be unique. That's very important for when you're labeling stuff, because if I'm saying north 1, how would I know I need this north 1? Now in this case, it really doesn't matter since all the pieces are the same size. But what if each piece has something very unique inside of them? What if, let's say, we can make a quick case here on this. We can use the same centers and then add a circle here, right? And then we just do a tractor point, basically. We would just do remap numbers, put mapped here, very quick. Bounds, find the bounds of the target, closest point. Finds the distance in between them. Plug it in here. We'll add a quick cheeky little point here. Point. Already. And then it should be this probably. And then we add our own domain. And then we'll add 2. I don't know, something like this. And we can actually, I will disable this. So if you're doing some flattening operations and you see that both of these are dependent, you want to try to cancel those, I would say, or try to disable them so they don't try calculating, because when one's flattened and one's grafted, the data will get exponentially larger, so it'll take more computational time. So oops, not what I meant to do. So it's good to just right ahead just disable those. Okay, so right now should be the other way around, and then we'll put, yep, and it works fine. So as you can see, so yeah, each piece is very unique in their own way. So each piece is extremely unique now, because each circle is a different size. So my north 1 here is different than this north 1, because you have, we'll put 0.25, so we have a definitive number. Okay, there we go. So it's like this north one is different than this north one. So you're like, okay, well, they can't. Then it would take me, I would have a 1 in 10 chance to make sure I have the right positioning. The columns are right. I can organize them by column, but I can't organize them by row. So what we need to do is, if we make a panel here, you plug this in, we see it says 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops, sorry, I'm scrolling too fast. My bad. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what I want is I want a row of 1s, a row of 2s, a row of 3s, and a row of 4s. The reason why is I want all these to read 1 and all these to read 2 and etc. So that makes now, if you think of these numbers as the rows and these are the columns, you can see that each column here is unique, 5, 6, 7, 8, etc. But each row is the same because of the numbers. So see 5, 6, 7, 8, 5, 6, 7, 8. That means all these row-based are not unique. They're pretty much exactly the same. So if it was pavers that have no detail and they're just squares, it doesn't matter. But if they're different, like we have here with all these circles, then it does matter. So what we need to do is we need to flip it. So when we do a flip matrix, we get them all on the same row. Now there's other ways to do this as well for counting, but this is the quickest way, I would say, to do it. You just add a list length, you have a series, and then you can just plug this in, and now each one is unique in its own way, or should be unique in its own way. I just saw one, I think I just zoomed in on 5, 5, and I was like, oh, that's not right. But, so 1, 1, you see 1, 1, sorry, I keep pointing at the screen, but you guys can't see that. 1, 1, and then 1, 2, and then 1, 3. And you have 2, 1, and then 2, 2. So those now are very unique in their own way. Each piece has its own individual label now. So that's what I like to do with these. Another way you can do it, instead of labeling it by the center, you can do an MD slider. I would believe so. And then do a, what's it called? Perp. I know you can do this with surfaces. I don't know if you can do this with with curves or interior curves. No, I'm just not going to do that. Yeah, it doesn't make sense. What I would do if I went in the corner, that's what I was trying to do earlier, or so you can change it parametrically. You could make them all surfaces, but that's just more computational time. So I wouldn't recommend doing that, So, because creating surfaces is not computationally efficient for just trying to put a point here, and all the calculation just to put the point exactly where it needs to be. I probably could evaluate the interior of the curve. Anyways, so that's how you would make unique labels here. So we can clean this up a bit too. So right now we have 2 north 2. So we can also just add a space here that we already have. So we do, well, that's not what I meant to do. We add another dash here. We can use the same dash. So 2 dash north dash 2. It's like a multiplication table if you really think about it. But we want to make sure that each one is unique in its own way. So we know that this is the 10th piece in the first row, the 10th piece in the second row, 10th piece in the third row, 10th piece fourth row, 10th piece fifth row, 10th piece sixth row, etc. So, and if you're still in the design phase, you can still change your designs here or your attractor points and be able to have those labels still remain consistent. And it just saves you a lot of time. Instead of having to, you make the labels once, because the labels shouldn't change. It's just your geometry may change. So you can actually start to manipulate it in its own way. So, and then your labels will always remain here. Okay, so, and then once you have that, you can bake it. Oh, what's running right now? Oh, point. You can bake it. We bake this. And if you have this issue, I can show you how to fix that. So we got a bake here. Okay, so we see this text and we're like, oh, that's pretty big. So we want to go to options. You go to annotation styles, and disable model space scaling, and they'll return to how it's supposed to be. And that's how you would label pieces. And that's one way of using concatenating as well. This is, I think, one of the most basic ways of using concatenating that I know of. Concatenating is used for a lot of different things. So in the later on the tutorials, when we go over these other ones, concatenating is still very important, and it still is. We'll use concatenating in C# as well. So we can use C# inside of here. If it will open, will it open? Will it blend? Oh, it just crashed. Oh, nope, we're good. So we can use C# in here as well to concatenate our own custom text too. Because this can get pretty large really quick if you make like G code, for example. Like you have 100 different things going on. It just gets massive. You don't need all this, and then it's bigger for no reason. So that's one way of using concatenating. So yeah, I think that's pretty much it. If you guys want access to the script, it is below in the Google Drive link. You guys can download it. And in fact, let me save it. Oh, I don't know where this is supposed to be saved. Okay, well, I will save this later. So anyways, all right, well, I think that's pretty much it. And that's all I have for today. And I think, I hope this was useful. I've used this at work, and the application I have using this at work is labeling pavers that we needed to do as well. So, and then making a unique label for each one of them in order when they're in production, they know which ones we're making. So we don't lose track of them. And yeah, I think there may be other stuff I want to do as well. Let me think. I've used concatenating for a lot of different things. But yeah, that's pretty much it. Thank you guys for watching. I hope you guys have a great day, and I will see you guys later. Take care.